Lesson 4 of the additional maths course, where I'm going to be focusing on the factor theorem. Okay, I'm going to have two parts to this lesson. So I'm going to go through two separate worked examples and two separate chances for you to have a go yourself at similar questions. Before I go through this question here about the factor theorem and explain what the factor theorem is, I'm just going to do some work explaining some prerequisite knowledge, some things you need to know before you do this lesson, okay, before you go through those two examples. So things you need to understand. So let's talk about functions. So let's say I have this function f of x equals x squared plus 3x minus 10. This is a quadratic function, okay, and it can be sketched quickly if I look at the roots of the quadratic function. Hopefully, in your GCSE course, you have done some sketching of quadratics and you've done some solving of quadratic equations. Okay, those two are linked. If I write this quadratic in its factorized form, so x plus 5, x minus 2, that will help us sketch this quadratic function. Okay. Sometimes, by the way, you see f of x equals, sometimes you see y equals. The y and the f of x are interchangeable. So when you have your sketch, your axes, you always have your x-axis, and then your vertical axis is sometimes the y-axis, sometimes the f of x-axis. Okay, so y and f of x are equal to each other. So let's say we got y equals x plus 5, x minus 2. That means I could sketch the quadratic function quickly on an x-axis by knowing the two roots that the quadratic is going to go through. I should know already that quadratic functions have either a U shape, so like a valley, or an N shape, okay, like a hill, depending on whether it's a positive quadratic or negative quadratic. This one is a positive quadratic because the sine of x squared is positive. It is positive x squared. And therefore it'll be a valley shape, okay, a U shape. This one cuts through the x-axis at two different points. So it'll look like that. And the two different points it cuts through are called the roots of the equation, the roots of the function, okay? And those two roots are based around the values which make either bracket in the factorized form equal to 0. So those two roots are minus 5 and 2. Because minus 5 as an x value would make the first bracket 0. And 2 as a value of x would make the second bracket 0. And if either bracket is 0, then the value of y will be equal to 0 because it is y is equal to this bracket multiplied by this bracket. And in a multiplication, if any value is 0, then the entire multiplication is 0. So these two brackets are called factors. X plus 5 is a factor of the quadratic. X minus 2 is a factor of the quadratic. These two values, minus 5 and 2, are called roots. Those are the roots of the quadratic function. Okay, so that's important knowledge to have first, which helps us when sketching different functions, not just quadratics. So let's say I had a different function, this function, if y is equal to x plus 7, x minus 6, x plus 3.2, that there is a cubic function that's in factorized form, okay? And straight away from that cubic function, you know what the roots are. You have 3 factors, and because you have it in factorized form, you know 3 different roots, okay? The 3 roots are minus 7, 6, and negative 3.2. So if x is any of those 3 values, then y will equal 0. So I know this function will go through the x-axis at those 3 points. Since it's a positive cubic, I know the shape will be something like this, and since it goes through 3 times, I know it'll look something like that. So that one will be -7, that will be -3.2, and that will be 6. And hence, having the factorized form enables us to sketch it very quickly. Okay, so the factors lead us to the roots. And also, if I have roots, then they can lead me to the factors. Okay, so for example, if I have this function, y equals x cubed plus 6x squared plus 12x plus 7, if I am told that one of the roots is the number -1, so if I'm told that the cubic looks something like this, so if I'm given a graph of the cubic and it goes through at -1, then I know a factor of this cubic. Okay. If -1 is a root, then I know that this cubic can be factorized with x plus 1 as one of the factors. Okay. So that's the prerequisite knowledge. Factors lead to roots, and roots can lead to factors of the polynomial. Okay, so let's have a look at the first question. Show that x minus 3 is a factor of this cubic f of x equals 2x cubed minus 7x squared plus 2x plus 3. To show that x minus 3 is a factor, all I need to show is that 3 is a root. Okay, so if x minus 3 is a factor, then 3 is a root. That means that if I substitute 3 in instead of x, the value of y should be 0. I don't need to have it in factorized form to do that. All I need to do is simply substitute a value of 3 in, and if the entire expression results in 0, then I have shown that 3 is a root, and hence x minus 3 is a factor. Okay, so let's do that. So I'm going to substitute 3 in, so I'm going to plug 3 into the function. So I'm going to find f of 3. So I do 2 lots of 3 cubed minus 7 lots of 3 squared plus 2 lots of 3 plus 3. 3 cubed is 27, so 2 lots of 27 is 54. 3 squared is 9. 7 lots of 9 is 63, so let's take away 63. 2 lots of 3 is 6 plus 3. And if you simplify that, 54, take away 63, add 6, add 3, you get 0. And since that is what I was looking for, then 3 is definitely a root because f of 3 is 0, and hence x minus 3 must be a factor. Okay, so we put and therefore x minus 3 is a factor of f of x. Okay. In algebraic terms, in general terms, the factor theorem states that if x minus a is a factor, then f of a will equal 0, and vice versa. So if you know a factor, then the value of x which will make that factor 0 makes the entire expression 0. So if x minus a is a factor, then substituting a instead of x will make that bracket 0. So substituting a into the entire function should make the function 0. And also, if you know a value which makes the entire function 0, then that will lead you to a factor. So if a is substituted into the function and makes it 0, then x minus a is a factor. Okay, so it works both ways round. Okay, so keeping that in mind, so keeping that example there, I want you to have a go at this question. Show that x plus 1 is a factor of the cubic f of x equals x cubed plus 3x squared minus x minus 3. So pause at this point and have a go at that. So you're trying to show that x plus 1 is a factor of this cubic using the factor theorem. So show in the same way that I showed that x minus 3 was a factor of the cubic in my worked example. Okay, pause, and then I'm going to go through the solution. Okay, so hopefully what you did is you realized that if x plus 1 is a factor, then minus 1 would be a root. So all you need to do is you need to substitute minus 1 into the function. So find f of minus 1. So substituting it in instead of x, you get minus 1 all cubed plus 3 lots of minus 1 squared minus minus 1 minus 3. Minus 1 cubed is minus 1. Minus 1 squared is 1, times by 3 is 3. Minus minus 1 is plus 1, and take away 3. And that gives us 0. And that's exactly what we wanted. If minus 1 leads you to 0, then x plus 1 is a factor. So all you need to say now is, therefore, x plus 1 is a factor of f of x. And you are done. The nice fancy way of saying it is QED at the point where you got 0. It's Latin for quod erat demonstrandum. It means basically which was what was required or which was what was wanted. Okay, this is the result I wanted, and it proves what I wanted to show. Okay, well done if you got that right. If you plugged in minus 1 and you got 0, then you're done. Okay, now I'm going to move on to part 2 of this, which is using the factor theorem to factorize cubics. Okay, so you are probably used to factorizing quadratics. At additional maths level and at A level, you will be expected to factorize cubics. Okay, often they will give you a hint and they will give you a linear factor already. Okay, and in a previous lesson, I've shown you how to divide a polynomial by a linear expression. Okay, but imagine they don't. Imagine they just say, fully factorize this cubic. We're going to use the factor theorem to find a linear factor, and then that will help us do the rest of the question. So what we need to do is we need to find any root which will make this function 0. And once we've found a root, we've got a factor. Okay, we know that this cubic will factorize, hopefully, into 3 linear factors. Sometimes it doesn't. Sometimes it factorizes into a linear and a quadratic. Sometimes it doesn't factorize at all. Okay. Hopefully, this will factorize into 3 linear factors. So what we will get as a result is we will get something like this. Now, the 3 numbers at the end, you know, are going to multiply to make minus 15. So you have an idea already about numbers that might be in these 3 brackets. Okay, you know one of the brackets is going to have a 2x, and the others are going to have x's in to make them multiply together to make 2x cubed. So the three numbers will multiply together to make minus 15. So have a think about what numbers you could possibly have in those brackets. You should be thinking that maybe there might be 1s, there might be 3s, there might be 5s, there might be 15s in there. Okay. So if any of them had 1 in, so let's say that one had 1, it would either be x plus 1 or x minus 1, which would mean a root would be either 1 or minus 1. Okay, if it was x plus 1, then minus 1 would be a root. If it was x minus 1, then positive 1 would be a root. You wouldn't have a 2, probably, okay, because multiplying to make minus 15, 2 is not a factor of 15, but you might have a 3, plus 3 or minus 3 there, and so negative 3 or positive 3 might be roots. So ideas to try to find roots will be 1 and minus 1, 3 and minus 3, 5 and minus 5, 15 and minus 15. Those are the sensible things to try as your roots. So I'm going to start with 1 and minus 1, the easiest ones to try. So f of 1. 2 times 1 cubed is 2. 3 times 1 squared is 3, so 2 take away 3. Take away 32 times 1 is take away 32. Take away 15. No, that didn't work. Okay, so 1 is not a root. That doesn't make 0. So let's try something else. I'm going to try minus 1. 2 lots of minus 1 cubed is minus 2. Minus 3 lots of minus 1 squared is minus 3. Minus 32 times minus 1 is plus 32. Minus 15. No, that doesn't make 0. So minus 1 is not a root. Okay, so I start again. Now I'm doing 3 and minus 3. F of 3. 2 lots of 3 cubed is 54. Minus 3 lots of 3 squared is minus 27. Minus 32 times 3 is minus 96. Minus 15. Nope, that does not make 0. Okay. So I start again. And now I try minus 3. F of minus 3 makes minus 54 minus 27 plus 96 minus 15. That is equal to 0. Hooray! Finally, I found a root, which means I found a factor. So I can say, so x plus 3 is a factor. So this factorizes into x plus 3 multiplied by 2 other factors to make the cubic. At this point, I use the skill that we've learned in the polynomial division lesson, and I divide this cubic by this linear to find the rest of the factors. Okay, x plus 3 times what makes 2x cubed minus 3x squared minus 32x minus 15. So I'm going to go through that relatively quickly because it's a previous skill. X and 3 multiplied by some quadratic will make this cubic. So I want 2x cubed, so this needs to be 2x squared, which makes this 6x squared, because 2x squared times 3 is 6x squared. I want minus 3x squared, so this needs to be minus 9x squared, which makes that minus 9x. Minus 9x times 3 is minus 27x. I want minus 32x, so I need another minus 5x, which makes that minus 5. Minus 5 times x is minus 5x. Minus 5 times 3 is minus 15. And is that what I had? Yes, that's perfect. That's exactly what I had. So I'm nearly there. So I know that 2x cubed minus 3x squared minus 32x minus 15 is equal to x plus 3 lots of 2x squared minus 9x minus 5. And now, to fully factorize it, all we need to do is try to factorize this quadratic part into 2 more brackets. And hopefully you have practiced that at GCSE level, factorising a quadratic. We know that if it's 2x squared, one of the brackets is going to be 2x, the other bracket is going to be x at the start to multiply to make 2x squared. I need 2 numbers to multiply to make -5. There aren't many choices. It'll be -5 times 1 or 5 times -1. And I have to decide which way round they go, either the -5 or the 5 there, or the -5 or the 5 there. Okay? In order to make -9x, I want the -5 there, because -5 times 2x is -10x. And then 1x together will combine to make -9x. And there we go. I have factorized it fully, and that's the fully factorized version of the cubic. Okay? That's a lot to get through, but remember the process. Firstly, trying to fully factorize it, you try different values that seem sensible. Here, remember, the last number was -15, and so you tried things like 1 and -1, 3 and -3, 5 and -5, 15 and -15, until you find one that makes the value of y 0. Then, because of that, you have a factor. And then you use polynomial division to find the quadratic part of the factor, and then you factorize that into 2 further brackets. You could, if you wanted to, keep trying more numbers until you've got more factors. I could have tried 5 and -5, and 5 should have worked. 5 would have made it 0, and then I would have had an extra factor. But it's difficult to find this one here, because the value that works to make the middle bracket, the 2x plus 1, would be -1/2. And I'm not going to sit around and try lots and lots of different numbers and different fractions as well until I've got it. Once I've got one, I'm very happy with polynomial division, so I know that's going to lead me to an answer. Okay, so here is the question I want you to try and do. I want you to fully factorize the following cubic. F of x equals 2x cubed minus 7x squared plus 2x plus 3. Okay. So pause the video, have a go. Okay. Try different values, find a factor, use polynomial division, and then fully factorize. Okay, I'm going to go through the answer now. So I would have tried 1 and -1, and 1 actually works straight away. F of 1 is 0. And therefore, these 3 dots means therefore. Therefore, x minus 1 is a factor. Via the fact theorem, if that's true, then this is true. And hence, I can use polynomial division with x minus 1. I know I want 2x cubed, so this has to be 2x squared. So this has to be minus 2x squared. I want minus 7x squared, so this needs to be another minus 5x squared. Hence, this needs to be minus 5x. Hence, this needs to be 5x. I need to have 2x, so I need minus 3x from the minus 5x to get the 2x. So this has to be negative 3, and hence negative 3 times negative 1 is 3, and that is what I have there. So that's perfect, that works. That checks it through. So f of x is therefore equal to x minus 1, 2x squared minus 5x minus 3. And then factorize the quadratic into 2 further brackets. And what you get is 2x plus 1, x minus 3. And that is the fully factorized form of that cubic. If you got that right first time, superb. Okay, it's very difficult to do, but if you follow the process and practice this, it becomes fluent, and then it becomes second nature, and you will be able to do it like that. Okay, so now go away and have a go at exercise 2.2. So that's the second exercise in chapter 2 from the textbook. Okay, and question 1 is like the first type of example. Questions 2 and 3 are similar to this, factorizing a cubic using the factor theorem and then polynomial division. Okay. With practice comes fluency. So make sure you use this textbook, practice and practice until everything is second nature, and then you become a mathematician. Enjoy.